That's pretty cool.
Every once in a while, I just
Okay, guys.
Guys.
Let's go over a couple more slope fields and
No, you're not. Everyone making fun of my head. Talking about your height, too. That's not funny.
No, because I thought I was gonna get to keep that last ball and then they took it back.
I can bring it back.
I was like, that's not very dinger of you.
I can bring it back. I'll bring you the one from Friday.
She said she gets dingers. Sheesh, dingers. Okay, let's do another. Well, let's circle all the way back to another example of a differential equation, which should hopefully be pretty lit and savage.
Good.
This one is a little challenging. Let's do this kind of weird one.
Which is this weird one?
Which one?
Which one is this weird one?
Oh, like 5D.
5. Okay.
Oh, yeah. Lainey said savage.
Oh, Delaney.
She didn't say lit savage.
Delaney. That's Griffin's sister.
That is correct.
Yep.
Thanks for the gifted subs. Okay. Look at that. It's pretty lit.
Okay, but you have to have your dad tell you some CDs. I'm not joking. I'm gonna text Barry and make sure he does.
Very good.
There's something about this that makes it weird. Does anyone see the weirdness?
There's no X.
The extra
There's
Y.
2 Y's.
Oh, we've done a few that already had
You just
Y's.
do Y times negative Y squared.
Y prime is positive and Y is negative.
It's these.
I don't even know what's going on.
We're different.
It's these.
Well, have we done one yet with a plus sign or a
I
minus
have
sign?
not.
I don't think so.
No, mostly just division.
No. What makes it weird is, let me show you, for example. Let's just get to the point here. So the point is, what you got to do. The trick here is to move both of these guys to the other side first. So might be like, well, what do you mean? Because I thought we had to get all the Y's on one side and all the X's on the other side. Now you're telling me that you want to do this instead. Well, the reason is what I need to do here is take this and then rearrange it. Well, I don't know, let me know if this is. Oops, I forgot the dy. Sorry. So once I have these guys over to the right side, I need to then divide by this to get it on the left side. So just take a second to think about that. Why was that necessary?
So all the Y's are on one side.
Is it because it has to be up together, like it's one?
Yeah, so I mean, the reason is you can't have something like y plus dy. That's not really going to work. So what you really need is to have an expression in terms of y, like times dy. That's the only way we know how to make it work. So do you guys get?
Yeah.
How I got from here to here?
Yeah.
Are you all comfortable with that?
Mm-hmm.
So, and that's tricky. That's not that. I mean, that's very far from obvious, and that's the route you got to take. But that's what you got to do. So then, when you integrate. What is this going to turn into? Natural log of y minus 3. And then this becomes x plus some constant.
I remember this time.
What?
I remember the C this time. You got it.
All right, thanks for giving subs.
Yeah.
Are you sitting on your foot?
Yeah.
Okay, moving on.
Well, anyway, thanks for the 100 bits, Lillian. Appreciate that.
Where's the rock?
So, rearrange. You can say you go e to this power. And hopefully you're thinking, I know what's going to happen with this guy. There's a subtle difference at the end here. Are we okay with that?
Yep.
So this is going to become c times e to the ex, right? And so we end up with some constant times e to the x plus 3. There you go.
That's lovely.
That's lovely.
Yeah.
You can confirm, it's actually very easy to confirm that this satisfies the equation. Because if you say, oh, okay, what's the derivative of this? The derivative would be c e to the x. And so if you plug into this equation, if you go, well, y prime minus y plus 3, does that indeed equal 0?
Mhm.
Yes, it does. So, confirmed.
Thank you. Wink.
Thank you. Feely report? How are the
Intact.
feelies? Feelies intact?
Fine.
No one's upsetting spaghetti? Nanobots flowing through?
Tomorrow.
My veins. They are
Give me
flowing.
second dose of the nanobots.
Oh, nice. Get those bots.
The bots are in me. Both bots.
Let's look at,
Both doses. Stay in there. Just going wee.
Well, now.
Mr. Bell, a funny story. My sister got really mad that I got the vaccine, and she was like, have fun not being able to have kids in the future.
Oh my God.
That was so funny.
you got memed. You got memed.
Epic. Epic.
Epic gamer moment.
Something
Yeah,
really going
yeah.
to harm her.
Hey, if I would be like, rejoice.
Yeah, I was like, am I going to be upset about that?
Rejoice. Is that song?
Yeah.
Emmanuel. Okay. Oh my God, your hair
Okay.
is so pretty right now.
God, you are all over.
Is there a day when I'm not
I'm
all
gonna
over?
do-
Yes, there are
This is
several.
13C.
I don't want to.
No, 13, sorry, it's
Some days I don't
13B.
say that.
I want to just do 2 more slope fields, and then I want to move on to some other lit stuff. This is 13B.
Emily different.
And maybe let's also compare it to 13. 13D is kind of interesting too.
Jesse.
I was like, oh,
No Christmas.
So again, you just have to do the slope field. You don't have to solve it. These would both be fairly easily solvable differential equations. But anyway, what we're concerned about is the slope field. So the slope field. So 1, 2, 3. Feeling extra today. Can we bring back extra? Can we start saying that again? That'd be pretty lit. Remember you guys used to say that all the time? Like, oh my goodness, you're being so extra. Please, guys, please. Also fetch.
The cats
That
are-
was a long time.
Oh. Okay, wow, look at that. Good job, me.
Impeccable.
Impeccable. First order of business.
That's actually very good. Well done. I'm impressed.
Thank you. I appreciate it. Watch this. Watch this.
Why are you laughing?
Watch
It's
this.
true.
Watch this. Memes.com. You ever seen one of these?
no.
The mask. Chakras aligned.
The way you made that actually made me really uncomfortable.
This is actually a
I've never
diagram
seen
of a
it
chakra energy field. See, it's like a Robert Ross, X over Y. So, where's a point where this would have a slope of like, I don't know, 0?
0, 0.
Either X or Y equals.
How about an example of like the point, X is 0 and say Y was 2, that would give me a slope of 0, right?
Get up on out of here.
13B is my favorite.
Yeah.
This is so
Does this make
exciting.
sense?
Yes.
So any spot where the x is 0 and the y isn't 0, I would put a 0 slope. Does that make sense to everyone?
Yeah.
How about a place where the derivative's undefined?
Anywhere where y
It's anywhere where, yeah, y equals 0.
Right? If you had
Defined.
2 divided by 0 as your y prime, that would be undefined. So that would be like kind of like the x-axis. Now, undefined slope, this is where it gets a little interesting because you're like, well, if you had like a spot where you basically had like a 2 over 0 form, that would kind of correspond to like infinite rise or a rise over an infinitesimal run, like a vertical line. Does that make sense? So these, long story short, these are going to be vertical.
Well, I'll be.
Well, you'll be. Yeah. How about if x and y are the same z-wamesies?
It'll be
It'll be the
one.
same way.
location.
So just for example, 2, 2 would give you a slope of 1.
Yeah.
So let's put those in. So points like 1, 1, 2, 2, 3, 3 would all have a slope of 1. Likewise, if they're both negative, you'd also have a slope of 1. That's kind of interesting. How about if x and y were opposite values? Let's say x was 2 and y was negative 2. Is this thought process making sense?
Yeah.
Okay, so. There we go. That's nice.
It's like a battleship.
No.
$1 million. I don't even know what shape this is describing. And then you got to then get a little creative with like, okay, a point like 2, 1. 2, 1 would have a slope of 2. And 3, 1 would have a slope of 3. And 3, 2 would have a slope of 3/2, and so on and so forth. So I just try my best to like draw those. Same thing with his negatives. I don't know, do you see it? See.
It's like,
Do you see?
I was right. It's the Wimpy Woodhouse.
The wimpy Woodows?
Yeah.
Why exactly, if it's undefined, would be negative vertical line?
It's not just that, it's more like the fact that it was a non-zero number divided by a 0 number kind of suggests to us that we're talking about a very large slope. Because like here, let me get a more specific example. So suppose x was 3 and y was 0.00001. Right? Suppose you were really close to 0, that would suggest that y value is big. Like really large. So then you kind of extend that reasoning to be like, okay, well, I'm gonna. I mean, that would literally be a slope of what, 30,000 or 300,000, whatever. Anyway, thousands, 10,000s, 300,000. So a slope of 300,000 would be, for all intents and purposes, vertical. So let me just for the sake of ease, we put that there. Are we cool beans there? Is this making sense or no?
Yeah.
So, and then just fill in the rest of the dots, and then so for example, the point 1, 3 has a point, or sorry, 1, 2 has a slope of 1/2. No, I'm sorry, 1, 2 has a slope of 1/2. Negative 1, 2 has a slope of negative 1/2, and the slope of 2/3 is a slope of 2/3. You get the idea, right?
Yeah.
Anyone know what shape it is? Oops, sorry, that's supposed to be more like, that's supposed to be way flatter.
Is it
Wimpy Woodhouse.
like a sideways? Oh! It's the thingies.
The
Yeah,
Wimpy
yeah.
Woodhouse.
The Wimpy Woodhouse. What are they called?
Hyperbole. They're hyperbolic curves.
Thank you.
I was
I couldn't
wondering
think of what it was
It's kind of
called.
like
But I didn't
this.
think there could be 4 of them.
Yes,
Now
I
here's,
love those.
well, no, not, you wouldn't
Yeah.
have all of them, but like one solution, like a particular solution to this might be like one of these curves. It would depend on initial
Oh,
conditions. So if you said something like, well, okay, your solution is known to have the point 30 in it. Then that would narrow you down to like, okay, I'm some kind of hyperbolic. Well, actually, it's a function, so you would just be limited to like one of them. Cool beans?
Yeah.
Although it's interesting because a lot of times you'll say, oh, there's nothing forcing you to say the solution has to be a function because like we've seen that circle can have a differential equation that sort of describes it. So, but typically you're looking for a function that satisfies the equation or slope. Okay. You guys sufficiently miserable yet? No, not yet. Not yet. Maybe a little minutes, but okay, good. That means I'm 5% of the way there. Just one of you guys, right? Math B May. Come on, no one likes Math B Mays. Sad,
Didn't get it.
sad.
I don't understand.
That's from memes.com.
An actual website. Memes.com exists.
Yeah, bro, you go to discords.com/Minecraft server, and then like you follow the link to memes.com. It's not that hard, dude. It's technology.
It really got a manual stuck in my head.
A manual
Song.
to like a VCR or something.
Yeah. Yep, that's
You
what
guys know
I
that feel when you forget to rewind your VHS before you return it to Blockbuster?
Oh,
That's a big
that's
move,
a big
no cap.
move. No,
Are you guys
the
not
worst,
relatable?
the worst is when you're trying to watch Austin Powers and then your freaking VCR eats your VHS tape.
Bruh.
And then you do no longer have Austin Powers on VHS, and it's really sad.
No. I know.
You have to get it on DVD for some ungodly reason.
Terrible. That's a,
Terrible.
That's a big move. That's a
do,
relatable move.
We do, in fact, still use our VCR, so there you go.
Okay.
Hall.
This one. Let's do this one a little more quickly. Where are all the points where x or the slope's going to be 0?
That.
The two axes. Anywhere where x is 0 or y is 0. Either way. So you have all these 0 slopes. That's nice. That's quick and fast. Okay. And then points like,
No. No.
get some easy ones. 1, 1 has a slope of 1.
No. Why?
1, 2 has a slope of 2, and 1, 3 has a slope of 3. We understand that? Now, there's a certain symmetry to this, which is that, well, what if x, instead of being 1, 1, it was -1, -1? It's the same thing. The product's the same. So 1, it's the same. And then so -1, -2 is 2. And so part of the fun of these is you're looking for symmetries. That'll not only speed up the process, but also make it more worthwhile to like think about what's going on in this differential equation.
I'm telling you right now that these are not
Yeah.
going to be very good drawings.
2, 1 gets you 2.
Yeah, but
I'm
some.
gonna just go there.
2, 2 gets you 4. So as you can see, like as you get over here, like 3, 3 is a slope of 9, which I mean, pretty much looks vertical. But
Yes.
just try your best to make them. I know that it's very difficult to be like,
We're literally just drawing lines. This is kind of weird.
oh,
Oh, how dare we?
well, we're
I
not.
can't deal with it.
We're drawing little segments that reflect the behavior of this differential equation. Okay. And you can see, so if your curve ventures over into the first quadrant, it's going to get really steep as you move away from the origin. That's what it's saying. How about the negative region? Well, if x is negative and y is positive, it's the same numbers, but they're negative, right? So think about the mirror symmetry there. Mirror symmetry, mirror symmetry, mirror symmetry. Is any of this getting through? Maybe, hopefully.
Yes.
Trying to.
Lines are pretty lines.
So you should be seeing a sort of, there should be a symmetrical sort of thing here. Almost looks kind of parabolic, but it's not.
It's
It's x cubed, isn't
Yeah.
it?
yeah.
No.
Right.
Oh, you can look at them.
And is it?
We'll keep going here. Well, you finish the rest of it.
Is it X?
While you're finishing your lines, I will, I'll solve it for you. Here.
Tan.
That will be how you'd solve it. So this would be a,
A line.
and so you'd end up with, which is an even function, which sort of, you can see that's what's going on. So if C is positive, you'd be somewhere up here. And if C was negative, you'd be somewhere down there. And so you can see the slope field is accurate. Okay?
Well,
Whoa. I love that saying.
Monkeys. Ever heard that one?
I have heard it. I just wasn't expecting you to say it.
It's a fun one.
It's a big move.
Monkey's uncle.
No cap.
No.
Respectful.
Cat. No cat.
No cap.
No cat.
All right. I hope we can just do one or two of these multiple choice.
Multiple choice. Somehow those are always end up being
These won't take long. I put them on here because it's like, well, this is one of the things that you're supposed to know how to do is like look at a field and say, well, which of these? It's an exercise in process of elimination. So I look at like 14, number 14. So what's the first thing you notice about that slope field?
all
Y
things
equals negative
on the
Yeah.
y.
Yes.
There's zeros,
So I'm not going to draw the whole slope field, but like you can see if you look in this region, you'll see all these flat lines. And what that tells you, it's like what Trey said, is this is the line y equals negative x. So what that tells you is that if x plus y equals 0, then the slope is 0. Do we all understand that logic?
Yeah.
Okay. So let's rule a couple out then. Look at the differential equations. Do you see how that rules out like, by the way, if it helps, pick an actual point like, oh, the point 3, negative 3 is giving us a y prime of 0. If you plug 3 and negative 3 into differential equation A, does it say y prime is 0? No, so A is wrong. How about B and C? B and C are still candidates based on just this piece of information. D? No. E? No, the denominator would be 0, but that would be more, anything that would be vertical tangent lines. So we're down to B and C. And then one more piece of information might be, well, look at the y-axis. These also have horizontal tangent lines. So this tells me anytime x is 0, I also have a 0 derivative. So which one's the answer? B. It's got to be B. So the differential equation, let me know if you got any questions on this. So just with this and this, because it's multiple choice and we're able to do process of elimination, you can infer that this has got to be it, because if you put a 0 in there, you get y prime equals 0, and if this expression is 0, you get y prime. No questions? Nope. Make sense? Okay. I said we're skipping 24, so if you missed that, we're skipping 24.
I think that these multiple choice are my favorite ones. I'm having fun with it.
Well,
Because
thanks,
it's just like, wee! You get to eliminate. I like it when you, okay, anyways.
Well, they were an enormous pain to make, so I'm glad that someone likes them.
Well, I'm sorry they were
I
an
thought
enormous
they
pain
made
to make, but it's really
Capital
fun.
T, they.
Oh, bro, I made all these.
Are you gay?
I'm part of
Are
Capital
you
T.
gay?
It's actually,
Oh,
you're
you're part of
fetching.
that group chat?
I'm part of the group chat, yeah.
You betcha.
Like that's the first time I listened to being part of the.
It's true.
E.
I think we've worn them
Sad.
down.
Sad. Okay. So, I'm gonna go over the last couple thingies here, okay? Like I said before, we're gonna move kind of fast in class and then UAP test people.
Supper.
You'll have extra time to complete it, but during AP testing week, we'll just be all work time to go and finish
Oh,
this.
this is the coolest.
This and the other problems that we're gonna only do a part of it. We're gonna skip most of it. Okay. Exponential growth and decay.
Oh, this is your unit.
I do like exponential growth.
Woohoo!
We'll see if it's carrying
Oh my
over
God.
into this unit.
What you're probably gonna like about this is 90% of it is just what we did last year with exponential growth and decay functions. And we're just adding on a little bit, which is, hey, did you know that you could actually write a differential equation that describes these processes? So 27 says, you got some bacterial sample. Here, they'll live in there. Gross, disgusting. Okay.
Like a cake.
Looks like a what?
A cake.
It doesn't.
These are supposed to be
Bacteria
the bacteria. But,
Yum.
It's a peach. I thought it was a cake.
so,
I didn't know what it was.
big spoiler alert. Hello, Mr. Crandall. What up, bro?
I mean, just for the spoiler alert.
Spoiler alert.
What great timing that is.
Of course it's me. Okay. I should have known. Hello, Mr. Crandall. How are you doing? I just sat down, which is allowed.
So, where was it?
Spoiler alert.
Spoiler alert. We've done this problem before.
Whoa.
Let's pretend for a moment that we had not done it. All we know is quackmolus. And I say, well, someone told me that this sample, it grows at a rate proportional, it's a big word,
That is a big word.
to its size. And it says, call the population P, no, Y, sorry, T,
Whoa.
Y, and let time be T. So obviously, Y is a function of T. Y is like it is all the time for a lot of time. I'm going to turn that into a differential equation. Because what kind of thing is this? Grows at a rate. Rate. What symbol do we usually use for that? Y prime. So it grows at a rate. So the rate is Y prime. Y prime is proportional to. So proportional to means let's, I didn't say which letter to use. So let's just pick a letter. I don't know. I'm feeling R.
Heck yeah.
So
That's
Y prime,
dangerous.
the growth rate, is proportional to the size of the population. Well, what's the size of the population? Okay. I don't know. Absorb that into your brain.
Absorb.
Do you see?
Yes.
This differential equation, it's one of the most fun, it's probably the most fundamental differential equation. What happens if you have a population there, its growth rate is just some multiplier times the size of the population, okay? So as the population gets bigger, it grows faster. Cool beans? All right. So let's solve that. Again, no spoilers. You guys know what the solution is, right? Don't say it. Right? So I'm going to solve this. Let's use our text.
Is R constant?
Yeah, R would be a constant. So for example, let's say R was, R could be like, let me give you a really concrete example here. Suppose R was this number, 0.05. And let's say currently the population was 1,000 bacteria. Well, what would the growth rate be then at this moment? What would Y prime be at this moment in time? 50.
Enough decimals.
Make sense? Suppose later the population had hit 10,000. What would the growth rate be then? 500. Right?
Yes,
Okay.
correct.
Do we understand the idea?
Yes.
So then we're going to say, okay, well, I get the basic idea. Let's. What's the actual function that does that? So let's solve this. Rearranging. Right? Don't forget, R is a constant. So it's just like any other number, 5, 2, whatever. Integrate.
What could be worse? I could be singing Emmanuel.
You could be.
We're still fine with that, right?
Yes.
Okay, so e to this power equals y. And we know what happens to that C1, right?
Get him out of here.
You get absorbed.
Griffin. Oh my goodness. It's yurt. It's yurt.
But I'm like, C is a fine letter, but I'm feeling P.
No.
Why bird?
Oh,
Oh my goodness.
No.
Oh my goodness gracious.
Oh.
Wow. Bonanzas.
Bonanzas.
Bonanzas?
Yes.
So that's all that is. It's just, well, there you go. So
No, there you
earlier
go.
usually they say this equation is so prominent, it's so ubiquitous that we're going to teach it to algebra students that even if you don't learn about calculus, you'll still know about it. Just 'cause it's like everywhere. So anyway, but there you go. So this is the famous PERT is just the solution to this really fundamental differential equation. In fact, that's where E even comes from. That's literally the definition of E is if you just set this equal to 1 and say what function is equal to its own derivative, the answer is, some number to the x power. What's that number? Well, it's E, Euler's number. So.
Good old Euler.
Okay, I think I'm reaching my goal now. You guys seem more miserable than earlier.
I'm
It's good,
more
especially
excited.
Aaron.
Have you watched Hidden Figures?
What?
Okay.
Watching
They
the
use
TikTok or
Euler's
something?
method in there. You gotta watch it.
Which one? He's got a bunch.
Yeah, no, you gotta see. You gotta
Okay,
watch
I
it.
guess we can watch it. I'll be in the theater, be like, Euler's method! Get
I don't think it'll be in the theater because it came out a
It
while
came out
ago.
like 2 years ago.
Good
But-
one.
But
No, maybe it's so good they'll go and show it in the theater
Oh
again.
please! I would love to go see it
That'd
in
be lit.
theaters again. It's so good.
Sorry, I'll watch it soon.
No, it's not. You don't need to immediately, but it's very good, and it's about 3 of my historical
Hashtag girl boss.
idols. I don't know.
Girl boss.
Catherine Johnson. Okay, I could go about. I write about my essays, like my timed write essays. I almost always write about Katherine Johnson and the other 2 as well, Dorothy Vaughan and Mary Jackson. But I write about them a lot. They're pretty lit. Oh, and Bessie Coleman. Okay, anyways, continue.
That's the highlight, right?
Yeah, Bessie Coleman is lit.
I always mix up Bessie Coleman and Bessie Smith.
Yeah,
singer.
Yeah,
Same
yeah.
first name.
same first name.
Okay, so now part B. So we've established, I hope we understand this. So summary. This differential equation gives us this really famous form for describing exponential growth or decay. And then part B says, suppose that we observe time population. At time 0, the population was 1,000. And then 2 hours later, the population was 1,500. The question is, what's the particular solution? So we're putting this into different words, right? You gonna make it, Kate? You okay?
No, none of us will ever make
No,
it.
you guys.
Jay Hall, we're seniors on the longest year ever. Okay?
Yeah.
This year has been so long.
It has been.
Like, we
Just
never got
finish
it
the
in.
problem.
Okay.
Pretty
just-
please.
okay.
No, I disagree.
I'm gonna finish the year out like this.
I haven't
Okay.
seen people in 13 months.
So you just go you have this information. So you say, okay, initial condition. That's going to tell me what P is.
Yeah.
How? Well, I
How?
plug in 0 for T, and I go, oh, wait a second. E to the 0 power is 1. Oh, sorry, I forgot to plug the Y value in. So I plugged in the T value there, and I plug in the Y value here, and then you go, okay, great. The P value is 1,000. Okay, great. That tells me that my function is Y equals 1,000 times E to the RT. I'm almost there. We got the P value is 1,000. Let's get the R value. The R value would be, well, now plug in 2 and 1,500 for Y. Use that data point. So kind of amazingly, once you have this assumption of this growth, you only need 2 data points to get your model. So you go 1,500. This is where the calculator is going to be necessary. Are we okay with that? Solving for R should be pretty straightforward. Divide both sides by 1,000. Take natural logs of both sides. Or you can think of as rearranging the equation, and then divide both sides by 2. Now, for you thinky winkies in the audience, this tells you a lot. This number is the factor by which the population grew over some time interval, and this is the length of the time interval. So that's a bit of a shortcut that you can realize that, like, oh, really? I mean, if you do a few of these problems, you notice, oh yeah, every time the R value is just the natural log of this growth factor divided by how long that growth factor took to take place. So, you ask the calculator, what is, I mean, my Google will do it for me. Hey, Google, what's the natural log of 1.5 divided by 2? And Google told me it's 0.20273. Okay. So let's put this into lay person's terms.
Okay.
The population is growing about 20% per hour. Now, the very new person to this would say, wait a second, that doesn't sound right. If you're only gaining 20% per hour, how'd you gain 50% in 2 hours? That confused me. And you'd say, well, bruh, as that growth was occurring, the population was growing continuously. And so, even after the first hour, that bigger population, you're going to get that extra growth. So yes, you can, with a 20% hourly growth rate, you can get 50% net increase over 2 hour period. Okay, now.
It's a lot of babies.
Part C.
Oh my God, there are so many babies.
Okay. Oh, here's a little side thought here. This is important for later, and it's important now too. Why don't we can really quick go back to the very beginning and say, based on this data, the differential equation was y prime equals 0.20273y. Are there any questions on that?
No.
So a fairly standard calculus question, differential equation question is, hey, assuming that this data holds, what's the differential equation that describes this exponential growth? And the process would be find the R value using your standard technique, and then just replace the R with that number. There you go.
You betcha.
You betcha.
That's the particular solution.
Oh, no, sorry. The particular, thanks, Trey. The particular solution is the function that actually does that. So,
Oh my God, there are so many things circles on this.
so this is called the general solution was this general solution. Particular solutions right here
Wait, which was the general solution?
is just the general form where you have these unknowns in there.
Oh, okay.
The particular solution is, well, if you give me this data, there's an exact function that does that. So like, if this was your differential equation, you'd always have this R value, but you might not have the same P value. You might have had a P of 10,000 or 1,000,000 or something. So you need 2 data points to get the full particular solution. Okay, and then the last part is going to be fairly straightforward. How long will it take to get to 6,000? That's back to just algebra, basic algebra. So for part C, you're going to set your function equal to 6,000. Like that. And then you solve it the exact same way you did before. So you divide by 1,000. Take natural log. And then divide by this number. So your time would be.
Big wheel.
Where
I got 8.84.
I believe you.
First mistake.
Make sure you're mindful of the units. All the time units earlier were given in hours, so any calculation you perform, it's gonna give you an answer in hours.
Yeah.
Okay?
Yeah. There was a moment, Jay Hall, over the weekend where I felt like everything failed me. And that was, Rafe and I were trying to figure out a math problem that was like, you had to, like convert inches to feet to like solve the problem. And then, but what we did is like, I converted the inches to feet and then solved for the area. And he converted the feet to inches because it was like a mixing. And we did not get the same answer. And we sat there for like an hour trying to figure out why it was different. And I was like, I feel like all of my math is failing me right now. And I still don't know. Like I was like,
I'll take a look at the problem if you want.
I mean, I'm sure it was us just being dumb, but like I was like, it's like I know all of this math knowledge and it's my favorite thing, and I still can't figure out this stupid conversion.
I remember a time where a professor had like just presented this really simple like mixing problem. Just one of those ones where it's like, oh, this solution is 20% alcohol, and this solution is 5% alcohol. If you mix this much and this much, what's the percentage of the outcome? It's like a middle school problem. And it's like stumping a lot of the classes. Like, oh my God. Like a bunch of undergraduates were like, as I'm saying, it happens. You know, sometimes
It happens, yeah. I felt really, really disappointed in myself though. I was like, I can't understand why the inches to feet is not the same as the feet to the inches.
Sometimes Paige will show me these like it'll be like the math work of some like little babies, and it's almost impossible for me not to go full actually. But like, well, actually, because sometimes it'll be like, you know, they're just asking them these questions about like,
Okay, well, the problem was that it was like, find the volume of this like area or whatever, and the, not of this area, but like of this thing, yeah. And so,
we're gonna do one more,
like
guys.
2 of the dimensions were in feet, and then the other one was like 4 inches. So what you had to do was like convert the inches to feet, and then multiply it all together, or convert the feet. But the thing is when I converted the inches to feet,
We're
and
gonna
then
do another one,
solved the
Jay Hall. We
volume,
better do
and
it.
then converted it back into inches, and he converted the
I got it.
feet, and but our inches were not the same. I was like, what?
So here's a stumper. How many square inches are in a square foot, guys?
Truly a mystery. Ask Mr. Isaac Newton.
Yes,
You might know.
How many square inches are in a square foot? 144.
Thank you.
Okay, so 29. We're running out of time. We'll finish it tomorrow, but I think we'll be able to finish it because it just says this is another classic question. This is actually the source of some memes after one of the AP exams where there's a question about a potato that annoyed a lot of people. But it was actually an easy question, but I don't know why people were upset about it. They thought it was too hard. But if we put this block is 150 degrees. We heat it up to 150 degrees. Now the room is at 67 degrees. This is the room temperature. Okay, do we understand the premise of the question? I'm going to do this in a little, sort of a funny order because I think what people miss on a question like this is they miss the common sense. There's some really simple common sense you can apply to this. But I'll start the differential equation. That'll show you why people often forget to use their common sense because they fixate on this differential equation. So the differential equation would be, it says the rate of change in the temperature of an object is proportional to the difference between that temperature and the room temperature. Do you understand that idea? So if you're an object and you're really far from the room temperature, you're going to cool faster than if you're close to the room temperature, right? Because you've probably seen this in real life, right? So the differential equation would be that the rate of change of the temperature, I'm going to use, we can use a y. You want to use y instead of big T?
Yeah.
Y is better? Okay. So we'll say y is the current temp of the block, okay? So you'd say the rate of change is proportional to This time it's not proportional to the temperature itself, right? It's proportional to the difference. So you could do something like this. Do we understand that?
Yeah.
And now, that doesn't look too easy, right? I mean, it's sufficiently complicated looking. Do something really simple though. Right now, when y is 150, what are we seeing? Y prime is r times 150 minus 67. But what's the block doing right now? It's cooling off. So what kind of number is r?
Negative.
It's negative. Okay. So now take it. We're jumping the gun here, sort of. But watch this. Here's my temperature versus time graph. What's the asymptote? Or what does this thing start at? Starts at 150. This is the common sense part that people are missing on these questions, is they don't think to do this. Starts at 150, that's obvious. And it approaches 67, right? If you come to the room, 24 hours from now, it's going to be, the block's going to be 67 degrees, right? So you know there's an asymptote, and you know that it's got to approach the asymptote. So what's kind of funny is you can actually figure out what this is. If I said hint, hint, it's an exponential decay. You can do this with pre-calculus, algebra 2 techniques, right? You understand? So anyway, tomorrow we'll solve the differential equation using standard techniques and show that you end up with this function, okay? It's a shifted exponential.
In chemistry.
It's really
Where we
similar.
do the same thing in chemistry where we do final minus initial temperature in order to find the rate of change between the
Probably, yeah. This is a really well-known law. Like, it applies to a lot of things.
So, you want to know something funny?
Why?
Randall sent me out of